Hello, dear students. So, here today I'm going to start the organic chemistry part. Okay, and the chapter number is chapter 12. I think the name is Organic Chemistry Principles and Techniques. Okay, so first of all, I would like to tell you what is organic chemistry. Okay, all of you are aware of this word organic. Many times we have heard of organic farming and everything. So, organic, it deals with mainly with the nature. Okay, in short we can say that whatever are the products of plants, okay, and animal bodies which are natural. Okay, so the study of these type of things, okay, which comes from the products of plants and animal body, when we try to study this type of things, so that comes under the domain of the organic chemistry. And chemistry, you should know that it is the what to say, it is the material science. Okay, so it comes in between this physics, which mainly deals with the uh, matter, I'm not matter, mainly deals with the space and everything about the outer these bodies. Okay, so be it space, be it the means everything related to the what to say, the outer things like the universe and everything. And the biology, it relates with the life, right? Means the humans bodies, whatever goes on and everything. So this chemistry, it deals in between, like it is neither artificial, I mean the space and everything, and neither it is completely the life. Okay, so it deals with the middle one, like it deals with the materials. And what because we see everywhere matter is present. Okay, so what matter is like composed of, what is the nature, what is the reactivity, and everything we deal about is with the matter. Okay, the reactivity, the what to say, the composition and everything. Okay, so this organic chemistry mainly deals about the so organic means, already have said you, it deals with the products of plants and animals, every natural thing. Okay, whatever we get from this mother earth. Okay, so this organic chemistry deals with such type of things. Now, the compounds mainly obtained from living sources, okay, living sources, that means plants and animals, they are called organic compounds. Okay, and those which are obtained from the non-living sources, that is, you can say rocks or minerals and everything. Okay, so they are classified into inorganic compounds. Okay, so based upon these, we will get two domains of chemistry. One is the organic chemistry, which I am going to start today, and one is the inorganic chemistry. So I think inorganic chemistry also clear to you what is inorganic chemistry. Okay, those things we will study, those in inorganic chemistry we will deal with the non-living sources, like the rocks and the minerals and the, okay, like these type of things. So first of all, what do we get when the scientists, they investigated a large amount of the organic compounds? They found that mainly these organic compounds, they mainly contain carbon and hydrogen atoms. Okay, they mainly, and some of them also contained few amounts of other elements. Okay, few atoms of other elements like nitrogen, like oxygen, phosphorus, halogens, etc. Okay, so whatever compounds which consist of only carbon and hydrogen, such type of compounds are known as the hydrocarbons. Remember, okay, hydrocarbons. And if they contain some amount of other elements also, like phosphorus, nitrogen, oxygen, along with this carbon and hydrogen, they are known as the hydrocarbon derivatives. Such compounds are known as the hydrocarbon derivatives. Okay, so these, see, also in organic chemistry we are going to mainly deal about the hydrocarbons and the hydrocarbon derivatives. Okay, so that means in indirectly I can tell you that organic chemistry will deal about the carbon and its compounds. Okay, I've heard that organic compounds chemistry, it deals with the carbon and its compounds. Now, why carbon? Why we say, why where every time we hear that carbon, it forms compounds with such a large variety. Okay, you will get many kinds of carbon compounds, which are, the shapes are very very different. Like it may be linear, it may be tetragonal, it may be tetrahedral. Okay, many types of compounds carbon gives us. So why such type of property? What is this kind of property found in carbon which other atoms they generally do not show? Okay, so one property here I like to mention is the catenation property. So you have learned it, I think, in your earlier classes. So you just try to find out, because I know what is it, so I will explain you. But as of now, you just try to find out what is catenation, then you will get your answer. Whatever question I'm asking, you will get your answer. Okay, so catenation you will try to find out. Now now one important thing, which is the tetravalency of carbon. Okay, so many times you may have heard that carbon only forms four carbon forms compounds with four other atoms. Okay, so that means what? That means the valency of carbon can be extended up to four, right? So you will not get carbon containing five bonds. Okay, so you will not get a compound where carbon is attached to five different atoms. Okay, but always you will see compounds of carbon where they are connected to four other atoms. That means they are tetravalent. Tetra means four. Okay, and the valency is 4. That's why we say that carbon is a tetravalent atom. Okay, because whenever carbon it forms at these bonds with four different atoms, okay, the structure which is formed as a result is the tetrahedral structure. See students, this tetravalency of carbon and other things I will tell you, mainly you will learn these in class, in your chapter 4 part 1. Okay, but since I am starting organic chemistry and I need to deal with carbon, I am just giving you a highlight. See, I am not explaining you why carbon is forming this tetravalency and not pentavalency. Okay, because if I go into such a detail, I have to start chapter 4 first, and that is not possible for me as I have been given organic chemistry part. So when you will learn this chapter 4, it will be very much clear to you. Okay, more clear. But as of now, you will not be confused. I'll just give you highlights so that you can deal with this chapter, but don't get confused. And you will learn it all in detail in your chapter number 4, which is the atomic bonding, I think. Okay, so now I'll just give you. So you have seen that carbon, if you draw the electronic configuration, you know carbon is what? The atomic number is 6, and if you write the electronic configuration, it is 2.4. So these, you know, this is the valency. Okay, this is the valence shell, right? This shell is the valence shell, and this valence shell there are 4 electrons. Hence you know that the valence shell electrons, it participates in bonding, right? So since there are 4 electrons in the valence shell, so these 4 electrons will participate in the bonding. Okay, and it is not so easy that this is 4 and the valence is 4. It is in detail we will learn in chapter 4. Okay, but as of now, since these 4 electrons are there in the valence shell, these 4 electrons they participate into the bonding. Okay, and that's why the carbon has 4 different electron, I mean this one. Okay, 4 different electrons which it can share or transfer with other atoms, and it can form a bond. See, bonds are nothing. Bonds are just a linkage between two atoms. If I say carbon is connected to hydrogen, that means there is a bond in between carbon and hydrogen. That means one electron, see, one bond is formed by two different two electrons. Okay, so two electrons make one bond. So here, since carbon is present here and hydrogen is present here, hydrogen is donating its one electron, carbon is giving its one electron, and they are forming a bond. That means mutual sharing is taking place, and such type of bond name is also there. This is the covalent bond. Already I have said you all these you will learn in chapter 4. Okay, I'll not go into detail. Okay, now, so you have to remember that carbon always forms four bonds with atoms. Okay, not three, not five, not anything. Okay, and the main reason behind it is its atomic structure. The atomic structure of carbon has four valence electrons, and hence these valence electrons take parts in the bonding process. And the structure which you get as a result, okay, is the tetrahedral structure. The name you have to just remember. Hmm. So the structure, these type of structure, like you have triangle, like you have circle, so this type of structure like a pyramid, you can see these are the tetrahedral structures. Okay, tetrahedral structures. Hmm. So you can see carbon here I have drawn, and these are the bonds, four bonds. Okay, and these points, these corners, they are the atoms. Okay, so these atoms may be hydrogen, okay, maybe any other atom also. So as of now you just consider hydrogen. Okay, and the bond angle, so the angle between two bonds, it is this one, 109.28 degree. Okay, so all these you will learn, no problem. Now when it carbon, the one of the reasons why carbon only tries to form these tetrahedral types of structure is that these type of structures are quite stable. Okay, quite stable means what? At a normal conditions it will not break down, because we want stability, because we are forming a compound. Okay, so we do not want that compound should, under the condition of temperature, under the condition of humidity, under the condition of stress, heat, it should not break down. We want that, right? Because in chemistry, whenever we are talking about any compound, any molecule, we want that molecule should be stabilized. Stabilized means what? It is not breaking down when we are applying heat. Okay, it is not getting affected when sunlight falls on it. Okay, it is not getting affected when say temperature is going down or up, like that. So this is stability, and carbon in its tetrahedral structure is very much stable because of this bond angle. Okay, so whenever there is a change in the bond angle, these molecule, the structure will come into stress. Okay, and hence it will break down under certain conditions. Okay, but here in this tetrahedral structure, the carbon atom is quite stable, and hence it mainly forms this type of tetrahedral structures. Okay, so I hope these things are somewhat clear to you. Okay, see, if I get time, I will try to make a video on this all things before chapter 4, so you will learn only. But as of now, you just need to cooperate. Okay. So now we will see that. See, mainly when we talk about hydrocarbons, we will get mainly two types of hydrocarbons. One is the saturated hydrocarbons, and another one is the unsaturated hydrocarbons. Okay, so whenever we talk about hydrocarbon, that means compounds of carbon and hydrogen. There are two types of hydrocarbons. One is the saturated hydrocarbon, another one is the unsaturated hydrocarbons. Okay, now under saturated hydrocarbons, what do you get? The bonds present, they are just the single bonds. Okay, and under unsaturated hydrocarbons, the bond present, they are multiple bonds. Like they may be double bonds, they may be triple bonds. Okay, so this is the difference between the two. Under saturated hydrocarbons, those compounds comes where the bonds present are only the single bonds. But in case of unsaturated hydrocarbon, the compounds, they form bonds which are multiple in nature. Like they may be double bonds, they may be triple bonds. Okay, so details of these single, double and triple bonds also you will learn in the chapter 4. So no need to get these confused. Okay, so under saturated carbons you have alkanes. Okay, I think you have heard about this alkanes. Okay, the general formula of alkanes is CnH2n plus 2, where n is the number of atoms. And under unsaturated hydrocarbon, you have two types. One is the alkenes, which consist of double bonds. Another one is the alkynes, which consist of the triple bond. I have given you examples also here, you can see. So, hydrocarbons, they are of two types, saturated and unsaturated. Under saturated, we have alkanes, which consist of the single bonds. Example is methane. You can see only the single bonds is present between the carbon and hydrogens, right? And under unsaturated carbons, hydrocarbons, they are the alkenes, which consist of the double bonds. Example is ethene, I have shown you. Okay. And under alkynes, you have the triple bond. An example is ethine, you can see here. Okay. Always you will see that I am trying to make carbon consisting of four bonds. So here you can see carbon, hydrogens are four, right? So a carbon is making four bonds with the hydrogen. Here you can see, when I write like this, C double bond C, that means already two bonds are present with each carbon, right? Now four bonds carbon makes, so two already made, so this carbon already made two, so one is this one three and one is this one four, right? So this carbon already made two bonds with this carbon. Okay, so now one is three and another one is four. So always you will try to make four bonds with the carbon atoms. Okay, because the valency of carbon, it is four, right? So like this you will draw the structure. Now one more terminology which you will get and you will not understand is the hybridization. And again, sorry to say, but you will learn these in also in chapter 4. So chapter 4 is very important to you, because I have also to start organic chemistry. I cannot wait for chapter 4 to be over. So I'm just giving you a highlight overview. Okay, and in this chapter you need not need details of these. Okay, now, so in hybridization, you have three types of hybridization. First one is the sp3, sp2, sp. Okay, now what are these s and p? I know you don't know. So you see s and p, they are the orbitals. Now what is orbitals? Orbitals are, because you know in an atom, is the nucleus, and there is the electron which is revolving around the nucleus. The nucleus is positively charged, okay, consisting of proton and neutron, and the electrons, they are negatively charged and they are revolving around the nucleus like this, like earth revolves around the sun. Same way, the atoms, what is there? Nucleus is there in between, in middle, which is positively charged, and the electrons which are negatively charged are continuously revolving around the nucleus, right? So these circular path is known as the orbit. But orbital orbital is that place in the atom where the electron resides. Okay, so there are places where electrons are found. Not everywhere you will get electrons in an atom. Okay, there are particular places, criterias, where you will find electrons in the atom. So that house is known as the orbitals, where you will get maximum number of electrons. Okay, so these s and p, they are the orbitals, okay, where you will get the electrons. And these s and p, they have different shapes also. Okay, like your house may have different shape. Someone may have assam type house, someone may have this rcc type house. Like these also orbitals, they are the house of electrons, and they have different types, different shapes. Okay, so these s orbitals have different shape, these p orbitals have different shape, like this. Okay, so based upon that, we will have three types of hybridization. Okay, one is the sp3. So these alkanes, they falls under the sp3 category. Okay, so these alkanes everywhere you will, if I ask you what is the hybridization of carbon in methane, so this is methane, this molecule. So this is the carbon atom in methane, I have marked now. So this carbon atom in methane is sp3 hybridized. Whenever you will get carbon connected to four different atoms, the hybridization will be sp3, and all are single bonds, right? Now sp2, these alkenes falls under sp2 category, means these alkenes are sp2 hybridized. Okay, generally. So here if I ask you in ethane this carbon, what type of hybridization it shows? It shows sp2 hybridization. Remember, in case of sp2 hybridization, the carbon atom should be connected to three different atoms. So you can see directly connected. Okay, so directly it is connected to only three different atoms. So why? Because you add these two and this is one, right? So 2 plus 1 is 3. That's why when carbon will be connected to three different atoms, the hybridization will be sp2. This is the trick. Okay, this is not the formal way. This is the trick you can understand. Similarly, in sp means alkynes shows this sp hybridization. So in sp hybridization, you can see 1 and 1, 2, right? So the carbon atom, if I ask you here, what hybridization it shows sp hybridization. You can see it is connected to 1 and 2 atoms. Sp hybridization. So remember, alkanes, they shows the sp3 hybridization generally. Alkenes, they show the sp2 hybridization, and alkynes, it shows the sp hybridization. Okay, and the shapes are also there. Like already I've said you, this carbon, it forms tetravalent structure. The shape is tetrahedral, right? Similarly, the names of the shapes are for sp3, the shape is tetrahedral. You have to write down, you have to remember. Okay, for sp2, the shape is trigonal planar. So tetrahedral, so I have already drawn and shown you. Trigonal planar is nothing, it is like a triangle. Okay, so this is in plane, right? So these three corners will be the three atoms. Okay, so trigonal planar. And when I talk about sp, the shape is linear. Linear means straight. Okay, so I need not draw these linear molecules. So this is the linear molecule, one is atom is here and one atom is here. So this is the linear molecule. So in tetrahedral, the bond angle also have told you it is 101 degree. In trigonal planar, the bond angle is 120 degree. You know the angles in a triangle, it is 180 degree, right? Sorry, not 120 degree. Yes, but in trigonal planar, the angle is 120 degree, and in linear, the angle is 180 degree. So angles are not very important. As of now, you just need to know that which hybridization has what shape. So I have written somewhere, you will not find difficult. So thank you. I'll make another video for the another topics. Okay.